All right, everyone, let's talk about MLOps and how it's transforming the way machine learning projects move from development to production. Now, MLOps isn't really a new technology. You can think of it as a culture built on principles and guidelines designed to bridge the gap between developing machine learning models and deploying them into production. In a way, it's like, with MLOps, the moment a model is created, it's ready to be deployed. MLOps helps break down the silos that traditionally separated data scientists, data engineers, and operations teams, allowing everyone to work together in a single ecosystem. So how does MLOps help achieve this? And what tools, practices, and principles make it work? Let's keep it simple. If you look at the needs of a machine learning project and the challenges of the traditional approach, you'll find the answers for why MLOps emerged. It wasn't invented overnight by any one organization or person. It developed gradually as companies faced these challenges and worked out solutions, which over time became the standards of MLOps. One major solution offered by MLOps addresses the friction that often exists between data scientists and ML engineers. Imagine if we had a standard protocol in place, like Jupyter Notebook templates, with predefined functions that allow everyone on the team to connect to the same databases, fetch data, and run jobs seamlessly. This way, we minimize the gap between research and production. Another solution is setting up comprehensive documentation. Data scientists can prepare detailed documentation for ML engineers, listing all the dependencies, packages, and libraries required for building the code. ML engineers then use this as a reference while deploying the code. Another essential part of MLOps is version control. We can't emphasize this enough. Version control in MLOps covers not only the code, but also data, environments, and model artifacts. By putting a versioning system in place, we make experiment tracking easier and keep track of different model versions, their data, and their accuracy metrics. This way, we can easily compare various runs and reproduce models at any point in time if needed. For example, if someone needs a model from a previous version, we simply retrieve it from the saved versions. This setup becomes especially helpful if team members move on, as it allows new people to join the project and get up to speed quickly. Then there's the question of performance. What if we start using distributed computing and containerization? Containerization has become a go-to solution for handling dependencies when deploying models. Technologies like Docker allow us to deploy applications in self-contained environments, with all dependencies packaged within. And with container orchestration tools like Kubernetes, we can scale these resources dynamically, based on demand. Next, let's consider automation. Rather than having to manually build, train, and deploy every model, what if we create a CI/CD pipeline, one that includes every phase of model development and deployment? By doing so, we put the entire model creation and deployment process into production, automating the workflow steps without manual intervention. Previously, every step was done manually. We'd ingest, prepare, and validate data, then train, deploy, and monitor each model by hand. With MLOps, however, our efforts shift from a model-centric approach to a pipeline-centric approach. Instead of focusing on deploying individual models, we focus on building an automated pipeline that lets us train and deploy models as needed, with just a few clicks, or even automatically based on triggers and schedules. Once the pipeline is up, we move into monitoring. With MLOps, we monitor data, features, accuracy, and other important metrics using tools like Prometheus and Grafana. These tools allow us to track data quality and detect issues with model performance, all in real time. And finally, there's the concept of continuous training. With MLOps, we set up a system to retrain our models regularly, triggered by events or set intervals. This ensures that our models stay up to date and continue performing well, even as data patterns evolve. So this is the core idea behind MLOps. It's a set of standards, principles, and tools designed to streamline and automate machine learning projects, making it easier for teams to develop, deploy, monitor, and continuously improve models. In the upcoming sessions, we'll dive deeper into each of these phases and see how tools like MLflow fit into this ecosystem. Let's get ready to explore MLOps in more detail.